Welcome to The Explainer. You know, we all see the AI revolution happening right on our screens. But what if I told you the real story? The one that's going to change everything is actually happening in the physical world. Today, we're going way beyond the chatbot to see how AI is being built, from the silicon up. When you think of AI, what pops into your head? It's probably a chatbot, right? Or maybe one of those incredible image generators, or just the latest software update on your phone. And yeah, that totally makes sense. That's the AI we interact with. But that's really just the tip of the iceberg. So this question right here is exactly what we're going to dig into. We're going to explore how AI is fundamentally reshaping the physical world, starting with the very chips it runs on. And then we'll see how that new foundation is turning AI into a real, actual collaborator in labs and design studios. Okay, so it all starts at the most basic level, the hardware. I mean, if you want to build a smarter, faster AI, you first need a smarter, faster brain for it to live in. And right now, there are two huge breakthroughs that are completely rewriting the rules of what's possible in silicon. First off, we've got to get our heads around two different sides of the AI coin. On one side, you have training. Think of this as the heavy lifting, the long, slow marathon of teaching an AI model in a massive data center. But on the other side, you've got inference. That's the sprint. That's when the AI uses all its training to make a split-second decision right on your device. And for that sprint, you need one thing: pure, efficient speed. And that focus on the sprint is exactly why this deal with Grok is so important. NVIDIA, which is already a giant in AI chips, isn't just buying some startup. They are snapping up world-class expertise in one very specific thing, making that AI inference faster and cheaper than ever before. It's a huge signal that the whole industry is shifting its focus to making AI work efficiently out here in the real world. All right, now for the second breakthrough. This one tackles a problem that has been a major headache for chip designers for decades. It's called the memory wall. Basically, on a normal, flat computer chip, the data has to travel a pretty long way from where it's stored to where it gets processed. That creates a traffic jam, and it wastes a ton of time and energy. So how do you tear down that wall? Well, a team from Stanford, MIT, and other universities came up with a pretty wild solution: a monolithic 3D AI chip. Now, this isn't just about making things a little smaller, it's a totally new way of thinking. Instead of building a sprawling city, they decided to build a skyscraper. And this visual just nails the difference. On the left, you see the old way. That 2D chip is like a big office park. Data has to shuttle back and forth between buildings, wasting energy. But on the right, you see the new 3D chip, the skyscraper. The memory and the processing are stacked right on top of each other, connected by what's basically a super fast data elevator. This vertical design absolutely slashes that travel time, making the chip insanely fast and way more energy efficient. So what happens when you have these incredibly powerful new brains for AI? Well, with this new hardware foundation, AI isn't just stuck inside the computer anymore. It's breaking out and becoming a true physical collaborator in engineering and in science. Take a good look at this number, 843. It might seem totally random, but it actually represents a massive leap forward for AI. Any guesses what it could possibly be? That's it. That's the number of individual parts in a complex Linux computer that an AI designed completely from scratch. It did everything: picked the parts, figured out the layout, the whole shebang. A process that takes human engineers months was done in just a few days. And the wildest part, it booted up and worked perfectly on the very first try. This really matters because it shows that AI can now handle a level of physical, real-world complexity that was unthinkable just a little while ago. You know, this is so much more than just a cool engineering trick. It signals a major shift in how we even think about AI. Like the quote says, we're moving from AI being just a tool, like a hammer, to AI being an active collaborator. It's no longer just a fancy calculator, it's becoming a partner. And you see this most clearly in the world of scientific research. So let me introduce you to Ayla, the AI lab assistant. This isn't an AI that just crunches data. No, it physically runs experiments in a real lab. And if you look at the table here, the difference is just staggering. What would take a human scientist hours of tedious manual adjustments, Ayla can do in minutes using real-time feedback. This is a total game changer, freeing up scientists to think about the big picture instead of being bogged down by the grunt work. And this new level of collaboration isn't just about making things a little faster. It's fundamentally accelerating the entire pace of discovery itself. By taking over these tedious experiments and even helping come up with new ideas, AI is pushing the very frontiers of science. A perfect example of this is DeepMind's AlphaFold. A few years ago, it absolutely blew everyone away by figuring out how proteins fold. But it didn't stop there. It's kept evolving. Now it can predict how those proteins interact with other molecules, which is a critical step for things like designing new drugs. The ultimate goal here is to turn it into a true AI co-scientist, one that can actually brainstorm and debate new ideas with researchers. And you can bet big tech is racing to build the models that are going to power this future. Meta is developing what they call multimodal AI, basically systems that can understand the world through a bunch of different senses, kind of like we do. They process text, images, video, and even physical spaces. The idea is to create a world model inside the AI, which is absolutely essential for building the next generation of smart robots and AR. So when you step back and look at the whole picture, it becomes really clear that the AI revolution is a full stack phenomenon. It's not just about the software and models that we see at the top. That layer is only possible because of the next layer down, AI's new ability to act in the physical world. And that is only possible because it's all built on a hidden foundation of completely new hardware. Each layer makes the next one possible. So what's the big takeaway from all this? Well, it's that we're in this amazing feedback loop. These fundamental breakthroughs in hardware are letting AI step out of the digital world to design physical things and do real science. And that, in turn, speeds up the pace of innovation for everything, including the next generation of hardware. It's a revolution that's happening all the way from the silicon up to the science. And all of this leads to a final, pretty mind-bending question to chew on. When AI designs the chips that run the AI that conducts our science, what's our role in all of that? What's left for us to discover? It's a question we're all going to be facing a lot sooner than we think. Thanks for watching.